Greetings for everyone. My name is Istva, and I'm a local lecturer and engineer on the Faculty of Engineering. And we started a project this summer where we are trying to define the properties of 3D printed implants. It came out from a sad story that happened to my daughter, who broke her legs, and the implant inside of his leg bended. Yeah, I was searching for that word, bended, and that's why it has to be taken out and changed. And it was, of course, a big trauma for her. So I was started to search what kind of processes are used for making implants. Especially, I wanted to know what kind of additive manufacturing processes can be used, and it came out that, of course, it was because at my daughter, the implant which was used was not for kids. An arm implant was taken and put into her legs, and the doctors didn't know what kind of stress, what kind of load it can take, and at these cases, maybe 3D printing is more applicable, because you can design an implant which can take a specific load. It can have a specific form and design. So what I found out, that direct metal printing is applicable for these kind of manufacturing of implants. And it's very rapid. There are no patterns needed, no silicone forming, no wax, and any other things. And maybe some post-processing, but not at every process is needed. So basically, two main methods are in this area, which are good for manufacturing implants with additive type. These are the sintering type of manufacturing and the melting type. The technical background is a little bit different, but the solution is good for this type of application at every one. I believe that the melting processes, like the selective laser melting, is better, or the electron beam melting, because it produces a constant mass of the metal, and maybe it is more developed. It is more developed material, but also regarding to the literature, also a DMLS, that direct metal laser sintering, is used with a very big approach and very widely. What metals can use? The basic material is a powder of that metal, which one you want to use. For medical treatments, steel, this kind of steel, titanium, and a special alloy of titanium is used, or a cobalt chrome alloy can be printed by melting or sintering. But every technique was already used. What can be printed? New generation implants can be printed with this kind of techniques. For example, what very unique is, mesh at the implants can be produced where the tissue can grow in and fix the implant more than at the classic methods. So we can see some usages here. What I've made, I wanted to know how fast this method can be, and today morning I started to design an implant for a leg implant, and I wanted to know how fast it is, and I could make it printed by an FDM printer, not in metal, but it's almost the same time. It takes almost the same time, and it took only 2 hours to design and to print it out. I had already the CT picture, the CT model of the bone, so that what already I hadn't go for. So just a few pictures about the design. I have took some design lines. A very basic B-spline is applicable for this project. I could follow the geometry of the bone very well, and I have produced some surfaces on the bone, and this was the solution. Actually, it can be seen. I took this small part with me. But yeah, why we should make some stress analyses for 3D printed implants is because these, as I told, these implants can bend, can break, some fractures can occur, and in unique cases, like for children, we have to produce implants which fits especially on that place and for the growing bone where no mass-produced implants are available. We can see some problems here. I've got some implants from the clinic here in Pécs, which were broken, bended, and so on in my bag. I can show it to you if you want. So the analysis method we used, as in that we have many years experience. We have designed a lot of things. For example, wind turbine towers. We have made thermal analyses. We have designed a small car, and this is a special one because this solution has been made on composite material, and some of the printed materials are behaving like composites because not the tensile strength is not equal in every direction at the materials. So sometimes we could use this for modeling. Of course, the mechanical properties has to be investigated at the implants, the specific materials. I found out that there are a lot of leaks in the literature which cannot be found. That's why we should make also some material testing to get for example, the modulus of elasticity, the Young modulus, the yield strength, maybe the hardness, but it's not necessary for the simulations. And now we have a machine which can produce this data for us. we have to determine these things by printing or manufacturing these test materials. And a simulation, and why it is necessary. If I could know what the implant can, what kind of load or what big load it can take before it were put into my daughter's leg, I would make some simulations and tell the doctors that it couldn't be applicable for her because maybe he or her has she has a bigger weight and or from other approaches. So we can give the angle of bending or the possible fracture with simulations, and thanks to the simulation we can reduce weight, optimize shape, and which very new is we can use maybe some kind of organic designs like here, very difficult forms to get the same mechanical properties, and it is maybe better for the bones not to lie on the neighboring surfaces of it, but to distribute the load also on the bone. This is that little implant I have designed, and what we want, and then this is the research for what we want to make, a parametrized 3D printed implants where I can give into the patient's weight, age, the healthy bone length, the bone periphery maybe, and the model will give out the implant which you can use and which is going to be printed out. So it can be maybe a revolution in implant manufacturing, because if the patient comes in after a serious accident, for example, we can make the implants within a few hours, and that is enough in traumatology. Yeah, we can give an optimized shape, calculate with calculated strength, and so on. And the advantages of this, there won't be any locking screws, if you know what it is, at implants. The locking screws are with the locking screws it's very hard to make the surgery because you have to fasten it very carefully through it. Through 3D printed implants, a blind surgery is possible. That means we can produce the tool immediately with the defined drilling directions, and that means the surgery time will be reduced, for example, to 1/3, and there won't be any fails and failures because everything is for that specific usage. And thank you very much.
Thank you, Mr. Alan Sheikh from the Department of Orthopedics, This is a really great presentation, and I hope in the near future it will be possible also here in page. I have just one question. As you said, for the design, you need the surface of the dough, but it's broken. So basically, you do not have the normal surface. So what can be the template?
Yes, that's true, but you can actually if you have the CT model, you can put together the parts, and actually you will get almost you will get the surface which you need, which you will see in the fracture.
So is it possible?
Sorry?
Is it possible?
Yes, you have to put it together. That's true. Like on the surgery. Of course.
Thank you.
Just one question about the material concern. I mean, what materials we use, because the body is highly intolerant of materials, but certain materials, and you are saying that you should print 3D print these materials. So what materials would you use, or maybe anything like that?
Those materials, which one I listed, are basically used in implant manufacturing. We can 3D print those already with these techniques, as I also listed there, the selective laser or electric beam melting or selective laser sintering. These methods, these techniques are good for that.
One quick question.
Yes?
I just wanted to ask what kind of software you use for designing these implants.
I'm an engineer, so I use an engineering software called CATIA. Well, I imported the mesh into it and used the basic verbiage for designing.
I have one more question, please. Is there a study of comparison of strength and physical properties between CNC milled implants and 3D printed implants?
As I know, we can reach the same strength at the sintering or melting process as in the CNC milling process. There are literature for that, but as I told you, these materials are have not always the same strength in every direction. So we want also to make some material testing, which didn't meet yet, but will.
Thank you.
If there is such a multi, I don't know how to say it in English, if there is a bone which is really broken for 10 parts, and there is no chance to put together the puzzle, you can have a CT, the opposite side.
Yes.
So this is really the daily usage. That's one thing. The other is if you want to touch such materials, which is laser sinter, please come to the first table and titanium, cobalt, and everything. Okay?
Yes, it's true that you can mirror the bone, which one you want to reconstruct, but it's not always good because not everything is symmetric in the human body. Thank you.